My name is Mike Sharpe. My call sign is Whiskey 8 X-Ray Hotel. A little over 39 years ago, I went to work for Digital Equipment Corporation. They hired me to help them sell PCs. There were no PC networks at the time, but there were networks between computers. And we'll get into that a little bit later, but they didn't think they needed lots of IP addresses, and they found out different. Anyway, managing your home private network. We're all amateur radio operators here, and we kind of have a background. The first rapid long distance communication was created by David Alter. You may not have heard that before. I certainly hadn't. He was a prominent American inventor and scientist of the 19th century. He was born in Westmoreland County, Pennsylvania, and graduated from the Reformed Medical School in New York City. And believe me, I'm not going to read all these, but this is kind of important. He had German and Swiss ancestry, and this is from Wikipedia. If you look at the bottom, he invented the electrical telegraph in 1836. And you're shaking your head. Well, a year later, in 1837, Samuel Morse independently created a practical physical electronic telegraph system, and in 1838 had created the Morse code system, which allowed for a standard way to pass information over long distances via the telegraph wire. So Morse was not the first one to do the telegraph, but he was the first one to create a system that he could use. The functionality of the telegraph was done by Alter, and I don't know if, I didn't look deeply into it, but I don't know if he took Alter's information and expanded on it, or did it separately with the information when they were discovering things like magnetic and electricity, and how the two were kind of coupled together. Anyway, fast forward to the 21st century. Boy, that was quick. Licensed amateur radio operators generally communicate on a one-to-one basis using different modes, which is what we call them, or protocols. Protocols is an important thing to remember. CW, RTTY, PSK31, ATV, amateur TV, AM, single sideband, FM, etc. Those are all modes for amateur radios, but they're also protocols, because you got to get from one person to another person using something between them that they can both understand, and that's called a protocol. So as licensed amateurs, we do communicate. That's what we're about, communicating. And many of these digital modes, such as PSK31 and a number of other digital modes, require a personal computer to handle both the transmission and reception of those modes. Here are some important terms to know and understand if you're going to have a personal network. A MAC address, a media access control address. It's a unique identifier that's used to identify a piece of hardware. And the piece of hardware is the network connection. So whatever your network connection is, whether it's in a big computer at home and you plug in an Ethernet connection, or whether it's over Wi-Fi, any way that you're using a connection, you have a device that translates digital stuff to Ethernet. And so you have to know that this physical piece of hardware is known and is unique in the entire world. A MAC address is the network card built into this. If you've got a PC at home and it's a bigger PC and you have two network cards for redundancy, then you'll have two separate MAC addresses, and you'll see you'll have two IP addresses. And if you also have, like this unit has a Ethernet connection in it for a wire, but it also has Wi-Fi built in. And the Wi-Fi card has a unique, what is it? A MAC address. Very good. So that's the first piece of information. You have to have a device that has a MAC address in order to get an Ethernet IP address. A gateway. Once you've got a way to connect to it, what do you want to connect to? You got to connect to a gateway because you're inside a local network. And your local network isn't physically connected to the internet except through a gateway. Okay. And we're going to talk about DNS servers. DNS servers stand for domain name server. It's like the phone book of the internet. When you type www.hp.com, the internet doesn't know what to do with that. So your computer, your web browser, when you type that in and hit enter, the web browser sends a message out the Ethernet to the network and says, what's the IP address for www.hp.com or amazon.com? So the DNS server's reply is the address that you want to go to Amazon is 108.174.10.10. Once your computer knows that, or your web browser knows that, then it sends out a message to Amazon, which is at 108.174.10.10. And bingo, on your screen is a bunch of ads from Amazon. That's their main page. But it's important that you understand that if your DNS server isn't working, or you don't have a connection to a good DNS server, you're not going anyplace on the internet with a web browser. So not just with a web browser, but anything. So any software that you run on a computer or your phone that you want to talk to somebody else, if you type in an alphanumeric web address, which is what most people, because are you going to remember from day to day 108.174.10.10 if you want to go to Amazon? But you can use www.amazon.com. Everybody uses that on their phones, on their computers, etc. So you got to have a DNS server, and we'll talk about where that is and how to get to it. Another term that you need to know and understand is a network port. When you have software that is doing something for you on the network, it uses a given port, and the port numbers go from 0 to 65,535. A port number is part of the addressing information used to identify the sender. So say you're going to talk to Amazon and you're going to transfer information back and forth. Well, it uses a particular port, and that port is port 80. That's the standard for doing for talking from a web browser to a website. Okay, that's the port that it uses. So actually, if we go back, the address that you use to get into Amazon would be 108.174.10.10, and then a colon 80 that says use port 80. So different software requires different ports so that you can have multiple conversations going on simultaneously over the network, and the information for your web browser comes in on port 80 and goes out on port 80. Your information for something else uses a different port so that the two can transmit simultaneously, but you don't lose connectivity. So it's not a one of. All this goes on all at once. Again, A port number identifies a specific process in the computer to which an internet or network message is to be forwarded when it arrives at a server or a PC. Ports are identified for each protocol and it's considered a communication endpoint. So it's the last piece in an IP address. So it's not part of the IP address, but when you use an IP address, it's there to say, who do you want to talk to? Do you want to talk to this program or that program? Okay. Again, network ports are represented by 16-bit numbers. From 0 to 1023 are restricted port numbers, and they're used by well-known protocol services. That's why 80 is in there. There are certain things that are used by everyone on the internet, and 0 to 1023 are reserved for those people. 1024 to 49151 are registered port numbers, which means it can be registered to specific protocols by software corporations. And so that's the rest of the world having special things to do their special stuff on the internet. And then all of the ports from 49152 to 65536 are used as private ports, which means they can be used by anybody. Now, why are ports important? Well, generally you won't be using ports that you know of. It's just all magic that gets taken care of. But if you should happen to have a Sherry from NAAR, Steve Smith, and you want to communicate via the Sherry, you can communicate out just fine. If somebody wants to call you direct coming in, your security system is going to say, nope, you can't get in. And you won't be able to have somebody connect directly to you unless you follow Steve's instructions and you set up port forwarding. And what is port forwarding? You follow his instructions. I'm not going to get into what they are, but you follow his instructions to set up port forwarding on your router. And then when you get, and basically you tell it to talk to the Sherry software on your computer if somebody wants to come in. Once you've set up that port forwarding, then Dave, you can contact you can be on a Sherry device yourself, contact my Sherry device directly, and it will say, oh, he's got the right port because we have a standard port that we use. And again, that's in Steve's instructions. So anybody that has that can then get through my firewall and connect directly to me, assuming my Sherry is on. Okay, so that's why ports are important. And until we started doing that kind of stuff, we wouldn't have had to know about Sherry. Got a question on it? What the question is essentially what Steve's what his instructions are to assign a certain port. His instructions are to tell you how to set up that. Yes. Yes, it assigns a port in your particular router so that then people can get to you. That's exactly what it's about. Okay, so those were all of the kind of things that you need to understand so the rest of it makes sense. We're going to talk about cable modems. We're going to talk about routers. And for those of you like me who want to do things wirelessly so that my phone will work as well, have to have a Wi-Fi access point. We're going to specifically talk about those things a little further down. But we started off talking about protocols. And, you know, PSK31 is a protocol with amateur radio. Well, for networking, for the entire world, there is something called TCP/IP. And that is the transmission protocol used for all internet access through ports, but if you don't have the TCP/IP, you can't talk on to everybody else. It stands for Transmission Control Protocol / Internet Protocol. So it's a transmission control protocol, and the /IP is the Internet Protocol. And as the slide says, it's a suite of communication protocols used to interconnect network devices on the internet. TCP/IP is also used as a communication protocol in private computer networks, which many people have at their homes. So it's the same protocol, whether you're only talking to devices within your own home, or if you're talking to the internet, and or both. Okay. So cable modem. So we talk about the protocol, but you have to have something that allows you to get to the internet. This little baby is a cable modem, and it has one Ethernet connection and one coax connection, because this is a internet cable modem for cable TV. So if your ISP, internet service provider, is Comcast, like it is for me, or Charter, or any of a number of ISPs, and you have coax cable coming to your house, you will plug it into a cable modem. And what this device does specifically is it takes the physical transport media, which is coaxial cable, and on that cable is an RF signal. And this takes that RF signal from the coax cable and translates it into a different medium that allows it to connect to an Ethernet connection. Now, TCP/IP is coming down that coax cable. So the protocol is the same. It's just the transmission media is different. So you got to translate it from coax to Ethernet, because Ethernet is what you connect all your personal stuff to and all your computers, whether you're in a private network or in a public network someplace. Ethernet is basically the physical media that you use to make those connections. The reason why they use coax is coax has a lot less loss, so it can get longer distances without having to have repeaters and so forth. So that's what most people use. Now, anybody here have fiber optics coming in? So you're getting your internet access from an ISP that uses fiber to the house. That's becoming more prevalent in larger in cities and so forth, because that's even faster and has more bandwidth. So you wouldn't call it a cable modem because the connection isn't cable, it's a fiber connection. But it does the same thing that this does. It translates from the physical media that you get it into the house with to Ethernet, which you can then run throughout your house or do Wi-Fi. There's also, there are a number of other connectivity pieces. So the most used is cable. The next most used is fiber. And then they've got a number of other things that have been around longer that not too many people use because they have cable and or the other. But bottom line is you have to have a physical way to translate how it gets to your house into something that you can use on your computers. So that's the cable modems, what you use it for. So once it's in your house, this is only one connection. Does that mean you can only connect to one device? Well, in the beginning, that was all you needed. That's what all anybody had. They were lucky to have a computer. But these days, I have, I think, 25 or 30 different devices in my house that are connected to Ethernet. So one connection doesn't help. And obviously, you got to be able to route it. So you could just use a switch, but you need to get, okay, what's that device? Well, I don't know. You need what's called a router. So you connect your one device, your one connection from the cable modem to a router. So here's the router connection, and then you can have up to 4 devices connected to separate devices. And what this does is it routes. Remember, I said every device has its own MAC address. And so what happens is when I plug in a computer into my router, it comes up and says, I want to go to the internet. Can somebody give me an internet address? And we'll talk about how that works. Let's see, is that, no. So basically your device says, here's my MAC address, assign me an Ethernet address. And the router, in fact, does that. So if you've got 37 different devices, each one comes online and it says, give me an address, and that's how you get your IP address. And then once that IP address is known on the internet, then people know how to get to you, okay? Now, this gets a single IP address, only one. You can have up to 255 internet addresses here. There's something called NAT, Network Address Translation. And basically, when you have a private network, it's one of 2 particular. Chris, can you go outside? I'm sorry, can you talk outside? Thanks. I've had enough problems. Okay. An IP address is 47.39.22.1. Okay, it's 4 particular sets of numbers, and every IP address has that. There are 4 billion standard IP addresses in IPv4, Internet Protocol version 4. It's been around for a long time, over 20 years. And when they first came up with it, they figured 4 billion, we're not going to ever run out of numbers, because at that point in time, you had big computers, you had smaller computers, but they were expensive, and there weren't going to be more than 4 billion of them in the world. Well, my watch has an IP address. My phone has an IP address. All of a sudden, 4 billion, we figured out about 10 years ago that 4 billion wasn't going to cut it. And so they have been working on IP Internet Protocol version 6. No, they skipped 5. Internet Protocol version 6. They've been working on that for about 10 years. And actually, a lot of the ISPs have moved to IPv6. But a lot of the equipment out there only knows how to deal with IPv4. So basically, what they did is they have software that converts IPv6 address to multiple IPv4 addresses, and that happens in your router. So NAT is the way to map multiple IP addresses, up to 255 IP addresses in a home, in a local home, to a single IPv6 address on the other side that's coming in to your house. So what is that doing that? So NAT, which happens in the router, it works like a telephone switchboard in a commercial office. It has a single incoming phone number. Once you connect to the switchboard, you're asked for the extension number to connect directly to the person or department who you're calling. That's how NAT works. So you get an IPv6 address into the modem sends it to the router, says, okay, router, you handle stuff there and we'll take care of it, translating back and forth. Now, there are two address groups that are typically used for private networks. 192.168.x.x and 10.10.x.x. And when you get your cable modem and you get into it to see what's there, you can find out what your local group is. And actually your router will magically give you a translation so that the systems inside your firewall or inside on your home side will be 192.168.0.1 or 1.1 and on up. So when they first started doing that, the numbers that you would see was always 192.168.1 and then either 1.1 through .254. All right. Any one of those numbers could be used inside your home. And oh, by the way, your house has the same numbers. So how do they differentiate between your house number 47 and mine? Well, the internal IP address is unique. So the IP address that comes from the internet is unique. And IPv6, instead of 4 billion, has 370 trillion addresses. A lot of equipment doesn't know how to deal with IPv6 at this point. And so they're using what they've been using for some time, that private network, because we ran out of IP addresses in the world about 6 or 8 years ago. And so everybody started using private network stuff inside their firewall. And that allowed you to not have to have a unique one of the 4 billion tied up all the time. Okay. Is this making sense? Okay. Network router. Okay, here's the other thing. DHCP, it's part of every router. DHCP stands for Dynamic Host Configuration Protocol. And it's a network management protocol used to automate the process of configuring devices on Internet Protocol network. So when you put a new system on your network, get a new computer, laptop, tablet, whatever, you don't have to get into it and say, let's see, I want IP address 192.168.1. Let's see, I've got 33, so 34. You don't have to do that. Almost every device that you get has built into it the function that's when you say connect to the network, it says, can somebody give me an IP address, please? Uses DHCP. It calls DHCP, which is in your router. Your router's running DHCP, and it gets that request. And it looks up in this table and it says, do I know about this MAC address? Oh yeah, this MAC address gets this IP address, here it is. If it's a new MAC address that it hasn't seen before, it looks through the table and sees what's the next one open and says, this is your IP address for the next 24 hours. And if you are continuously using it, it'll continue. But you may have a different IP address 3 days from now if you haven't used it for a couple of days. The thing is, the router routes. It knows what IP address is hooked to what MAC address. And then it knows to send the right things with the right ports to that particular physical device. And it's like the phone switchboard on steroids, all right? It handles all of that translation. when the DHCP server in the router gets a request for an address, it picks an address from its list of available addresses, releases that address to the requesting device for a limited time. Default time is 24 hours. Now, some equipment that you've got that's on the network, wouldn't it be nice if you didn't have to have a printer for every computer that you've got? You got 3 computers, and the way you connected printers before was with a cable from your PC to that printer. Oh, you got another PC? Well, you're gonna have to get another printer. Pain in the butt, expensive. There's got to be a better way. Printers that connect to the network. Oh, good. It's on the network. So what you do is you turn it on. And part of the setup in a printer is, do you want to use DHCP or do you want a static IP address? If you want a static IP address, in your router, you set aside the first 10 or 20, however many you want, of the IP numbers from .1 through .20 as static. And then the DHCP server will not use those addresses. When somebody says, I need an IP address, DHCP, it will use something from 21 on up. And then you can manually, in every device that you want to set up, like printers or scanners, things like that, you can manually get into them with their, like every HP printer that you buy has a little screen and buttons, and you follow the instructions and you type in what IP address you want to use, and you're home free. Now, why is that important? Well, if you've got 2 or 3 computers and 2 or 3 printers, wouldn't it be nice if one printer did one kind of things, black and white, another printer did color, and another printer was big size? And so you'd like to be able to send the print job to the one that you want. Well, you got to know the IP address, and if it keeps changing, you're twisting in the wind. So that's why you want a static IP address for some things. Your router has a static IP address, and your printer, my network attached storage device, which is all my music that plays throughout my house on Sonos systems, you got to have a static IP address for those devices, and for the NAS that where all of the music is, so that when you say, I wanna play Rod Stewart, this particular album, it knows where to go and get it, and it plays it, and you're in heaven, okay? If you like Rod Stewart. Bottom line is, sometimes you need static IP addresses, so you can either go to each individual device and manually put in a static IP address. And if you make a mistake and you two items with the same IP address, no, things aren't going to work, and you're going to wonder why. Or you can also purchase one of the better routers. And in the router that I have, courtesy of Mike Case, he told me about Ubiquity equipment. I looked into it, and it's professional equipment. It costs a little bit more than the standard stuff, but it's got a lot of features that are really nice. One of which is you can get into that particular router from a web browser and say, I see. So what you do is you got 30 devices you're bringing up. You let them all use DHCP and they get it. And then you have in your router a list that shows the MAC address and what IP address they have. Then with the better routers, you can get into that table and say, this is a Sonos machine and I want it to be number .20. This is my second one, .21, third one, .22, fourth one, .23. I can specify in the router what to do, and the next time those devices boot, they will automatically, they'll say, I need an IP address, and the router knows that's a static IP address, and this is the one for that MAC address, and none other. So it never changes. Yes?
So my question, I have an HP printer that is wirelessly connected to my PC.
Yeah.
But when my grandson say, oh, I recognize computer, Noah computer, and I recognize Dave computer, and then I get requests of print for both. Because it only prints for one.
Okay. Basically, what I think is going on here is, do you have a guest, a guest Wi-Fi access? And is that what your grandson is using? Of course it is.
Yeah, I don't, I just figured that.
Here's-
weird.
Okay, we'll talk about, we'll answer your question. Basically, for those of you that aren't here, Dave's question was, he says that he has a network printer that he can print to just fine. And his grandson occasionally comes over and wants to print something to it, and it won't connect to the printer. And why is that? Could have something to do with the Wi-Fi, and I think it does. The answer is many people have Wi-Fi in their house, and they don't want to make all of the things on their Wi-Fi accessible to casual guests that come in to do things. And so a guest account is set up, and there's an SSID. That's, I forget what SSID stands for, but there's an SSID for in-house, and there's an SSID for guest, and the two shall never twain. Never twain? Never. Blah, blah, blah. The bottom line is your guest account is set up for them to access the internet only. They can't see anything inside your inside network. So I'd be willing to bet money even that's the problem, because he's probably on your guest account and can only get the things. And so he can send it out to the internet and come into your system, no problem. But there's no way to do that for the printer. Pardon me? Service set identifier. Okay, thank you. The reason why I can never remember that is it's so off the wall. The bottom line is, we haven't talked about it, but a Wi-Fi connection works just like a regular physical internet connection. It's just that we've cut the cable and use two transceivers between the two so that you can do it wirelessly. That's why they call it Wi-Fi, wireless fidelity. I don't know. Anyway, so I think that's the answer to your question. And in order to, okay, if you're connecting to a device that has an Ethernet connection with a cable, it immediately makes the connection to the network because that's your box, and it knows, I want an IP address, please, and it gets its IP address, and then you're off and running. When you start cutting that cable, you have to have some function to keep people from driving by outside your house and getting into your system, and that is the SSID. One of the nice things about an SSID in Wi-Fi is the fact that you can, okay, if you go someplace like you came here and you bring up your phone and you say, I want to connect to the internet, and it comes and shows you a list of all of the Wi-Fi SSIDs. That's what those are. Well, you can hide that. You can have an SSID that's required and not broadcast it. So if your password is Yuck Bucket, okay, even if somebody knows that Yuck Bucket is your password, if they don't know the SSID, they can't get to it. So instead of automatically clicking on the show me all the Wi-Fi here so I can connect to something, if it doesn't show your SSID, if they know the SSID, they can put it in manually and then put in the password manually, and then they're in. But it's a security thing.
Okay. Actually, he has a meeting, so I'm able to access mine. We actually connected also the computer, the printer by Ethernet cable.
if it has an Ethernet cable connection in it.
Yeah.
And you can disconnect it from your network and connect it to him. Yes. No. Because, well, actually, if he connected physically to your internet, then he'd be on the same network. He would say, I need an IP address. He'd get an IP address, and then it would all work.
Yeah.
But then he has access to all of your personal stuff, which maybe is okay and maybe isn't.
Yeah.
Depends on what you got. Okay, anyway, so you understand now why some IP addresses need to be static and others can be intermittent and let the router route. And, oh, what's the next topic? Wi-Fi access point. Well, we kind of have covered that, but you need TCP/IP access to devices in your house or outside of the house, but you want to do it wirelessly. So that's what a Wi-Fi access point is for. Now, I've shown 3 different physical devices. Here's a single device that does it all. If you have an ISP and you are willing to pay their $16 or $20 a month to rent that device, it will be an all-in-one kind of a thing because it's cheaper. And they're all about making money. And if a problem goes wrong with any piece of it, they just replace it and fix it. So why do I have 3 separate devices? Well, because if something goes wrong, I can replace just the device piece that is bad. Also, like the ability to get into your router and set up those static IP addresses at one time on your computer, as opposed to going to each individual device and figuring out how to do it on that particular device, because they're all different. That functionality is worth having a separate modem and a separate router. And separate Wi-Fi, because you get a lot of routers that have Wi-Fi in them as well, and that's okay. But a lot of times, your cable comes into the house someplace, and you connect it where it comes into the house, and put it at the other end of the house. Wi-Fi doesn't work real well. And then you have to buy some kind of an expansion device or something. If you get a ubiquity Wi-Fi access point, and there are a number of different ones, they will use power over Ethernet. So all you have to do is run an Ethernet cable from your router at this end of the house to the middle of the house and mount that above a ceiling with that cable, and that cable will not only provide Ethernet, it will also apply power over Ethernet to power the device. Then all of a sudden you've got just one access point that's good for everybody in the house. Or if you've got a really big house, you can have one here and one here. Again, having separate devices gives you a lot more flexibility. Okay. Okay, internet service providers generally will provide you with one single device. Now, one of the things that Comcast has done recently is they provide one device and it's there. Oh, you want better coverage? We'll rent you another one for another $5 a month, and the two will talk and you get Wi-Fi throughout the house. Again, it's about the money. Okay, whiteboard time. Whiteboard time that's the end of my presentation per se. What time is it? 11:15. That's not too bad. We've been doing this for about an hour. Well, whatever. With my tripping over my tail here. Let's see. I want to get out of this. Okay. And now I'm going to share my screen. And I'm going to share that. Oh, come on. Get rid of that. Get rid of that. Get rid of that. Okay. So now I'm going to go here and share a screen. And I'm going to share that screen. Ah, yes, thank you. All right. Now we're going to do some live stuff. Oh, crud. There is some software that I highly recommend, and it's called Advanced IP Scanner, and it's in, I have a slide in here that has that, and you'll all be able to access this on the web to get the access to it. But this is on the screen, you can see, it's sitting there waiting. It's called Advanced IP Scanner, and it automatically looks at the IP address on your system and then sets up a number scheme. If you look up here, see right here where I'm scrolling, 192.168.1.1-254, that says, find all the IP addresses on this network. And if you click scan, it will scan and find.
We're just seeing the Google screen, Mike. We're not seeing what you're doing.
Okay. Yeah, I did. I'm sorry. My bad. Let's get rid of Google. Okay. Thanks for speaking up. I'd have gone on for a long time and not knowing you couldn't see what I was talking about because I could see it on the screen behind me. All right. So that's it. So now what we want to do. Yeah, that's what I'm trying to do. Damn it. Yeah, I know I am, but I can't. Thank you. I obviously don't use Zoom often enough these days. Okay, so I'm going to share a screen. And the screen I'm going to share is this one. Share. Are we good? Okay. It found two systems in this building. 192.168.1.11 and SS laptop, which is my laptop here. So I have the feeling that my laptop is not on the 192.168.1.x network. So what I'm going to do is I'm going to, let's see, I'm going to start a Windows PowerShell. And I'm going to go back to Zoom. Damn it. Oh yeah, I got to do this thing again. New share. Okay. Your screen sharing, I'm going to stop the share, current share. And now I'm going to share a screen. And I'm going to. Okay, can everybody see that? Little small. Crap.
Yeah, it's good. We can see it.
Okay, there's a command that you can give when you go to the command line in a Windows machine. And by the way, all of the things I'm talking about today, most of them will work with a Mac, but they'll work differently. You have to do different functions and so forth. If you got a Mac, you're on your own. Find somebody that knows Mac. I know PCs. PCs have, last time I checked, I think it was 92% of the market versus what Mac has. So anyway, there's a command called ipconfig, ipconfig space all. It will then tell me all kinds of information. Oops, and I did it wrong. ipconfig slash all. Okay. So if we look at the top, my host name is SSL laptop. That's the name of my laptop. The media Ethernet adapter is disconnected. That's because I don't have Ethernet connected in. Wireless LAN, media disconnected, finally down here, I've got wireless LAN adapter Wi-Fi. And notice it has right here, default gate, it has my address, which is 10.90.75.235. So I'm not on the 192.168 network, which is why it didn't show much. So I have to change that to the 10.10. Let's see. Where is the, so you can get all kinds of information here. Here's the LAN adapter. And so it shows my IP address, 10.90.73.235. But if you look further down, the DHCP server is 10.128.128.128. Now, that's pretty unusual, but that's probably because it's a public library and they want to do something a little offside. So I'm going to put in 10.128.128. Okay. So I'm going to go back to my advanced IP scanner. And of course, I want to change that. So stop the share. I'm going to share a screen again. And it's can everybody see this now?
Yes.
Okay. So I changed the numbers up here to 10.10.1. Oh, no, 10.10.128.1 dash 254. And let's see if, oh, was it? Okay. Thanks. This getting old is a pain in the patoot. 10.128.128.1 to dash 254. I don't think so. Let's see. Oh, there we go. There we go. Oh, there are a lot of 10.128s in this building. 96 alive, 0. Okay, if you look in the lower left-hand corner, 96 are alive, 0 dead, and 0 unknown. One of the nice things up here is you can, under view in this software, you can say show dead or show unknown or just show alive. And all I want to do is see the alive ones. So as you can see right here, the green line is still working on it. So it's looking. So if you look at the IP column here, you can see there are a lot of separate IP addresses. 175, 192. Now, I'd be willing to bet that if any of you have connected your phone to the network here so you could do things, if you looked in your phone as to what your IP address is, it would be a 10.128 number. Okay. Yeah, so they're playing games with it again because it's open, wide open. They're doing things that wouldn't be what I would do. Okay. So here's the gateway. Here's the AP router. I was hoping I would see something besides their stuff. Well, it's still got a few, it's at 95% so far. What's 254? Oh, yeah. Okay, it has 254 alive, and that doesn't make sense. So they may be doing something to spoof all this. I hoped to show you that you could see a lot of stuff, and on your own network at home, you will be able to see multiple things. This tool, Advanced IP Scanner, is really, really nice because you set it up, you get your network set up, then you run it, and then you can find things that you don't know what it is, but you turn things on and off until it goes away, and then you can actually tell it what is in that. So Sonus number 1, Sonus number 2, Sonus number 3, Sonus number 4 are names that I put in here under the comments over here, so that when I click on it, I know exactly whether they're up or down and what they are. And it will tell you the manufacturer. And so if it's Amazon, I know it's one of my Amazon Echoes. I've got 5 or 6. And what I do is I figure out which one is which, and then I, with that MAC address, say that's kitchen, that's basement, that's garage, that's living room, that's bedroom, that's office. And so then when I'm having trouble with things, first thing I do is I go to this software and say, what's going on right now? And I can see what's dead and what's alive. And I can, up here under view, you can say show dead, show unknown, and show alive. You can have all 3, and then you can just look at the unknowns. And is it connected? Well, it wouldn't be an unknown if it was connected, because if it had a MAC address, it would be in here. So that would be, it was live. Dead means you've looked at it once, it knows the MAC address, and it ain't on the network right now. Unknown is an IP address that has never been attached to a MAC address. And it's unknown because nothing has ever come up as that. Okay, so this is really, really cool software. And it's free. I give you the link. You can download it, install it on all your different systems, use it to your heart's content, and learn it. It's really, really cool. And if you get stuck, the site that you get it from, you can go to, and they've got help files, and it's a really nice tool. Let's close that. Okay. And let's see. Get rid of that. I want to share a screen, and that's what I want to share. No, it's not. Yeah. That's what I want to share. Well, this is the next to the last slide, so you can see it. Basically, the websites for additional information. There's a really good, about 12 to 15-minute YouTube video called Internet Protocol IPv4 versus IPv6 as fast as possible. They want to get to IPv6, but they've been working on it for at least 5 or 6 years. And I do know that my router at home has an IPv6 address out to the internet. And it does the translation to IPv4 in my home network just fine. So some ISPs have moved to version 6 already. And if you get, if you should buy a modem, you want to talk to your ISP and make sure you get one that will support the speed that you're paying for. So if you're paying for 100 megabits per second, you better get one that they say, yes, that works with our stuff at that speed. Or if you want 400 megabits or a gigabit, you can get it, but it's more expensive. I find that 100 megabits per second, I'm paying for 100 megs. I get about 120 consistently. Comcast is real good about that. Generally, they give you 10 or 20 megs over what you're paying for to make up for the times they're down. But you want to make sure that the cable modem that you buy is supported by them and will support the speed that you want. And if you start with 100, but you might want to go to 4, get one that'll do 4. You don't need to buy a gigabit one if you don't need it. And most homes don't need gigabit. I regularly run, well, no, I have tried and made sure it worked. Running 3 TVs on Roku's, running 3 different movies on 3 different television sets, and still done my stuff here. And I didn't even know that the TVs were on. 100 megabits is fine for what I need it for, and probably for anything that you will need in yours. But I highly recommend not paying their $16 to $20 a month for the rental, unless you're in a location that you're there temporarily and you're gonna move soon. So, but even the thing is, you can take it with you if you bought it, but it might not work with the cable company there. But if you're going to be there for a while, and I've been in my house for 29 years, I buy my separate devices. And when I had to buy a new cable modem because they upped the performance, and my old one wouldn't handle the 100 megabit. And that way I didn't have to, buy all 3 pieces, just the cable modem. So that's pretty much my presentation. I've kind of wandered around and so forth, but I think I covered the information that I wanted to cover for you. Questions? Comments? Oh. Thank you for coming. It's not bad, hour and 15 minutes. This is about what we did. And if you've got questions, call me, email me. I've been doing this stuff for a while. I've got a good friend who's also a customer, and for customer business, I charge him. But for his house, he had issues with his network and Wi-Fi specifically. So I got him to buy new equipment. I went out, spent, I don't know, a couple of hours, and he's tickled pink. Everything is working really good. And for amateur radio operators and friends, I don't charge. But seriously, if you have questions, do I know everything? No, but I know where to find out usually. Yes. I'm not. Good question. Question was, am I running a VPN? And my answer was no. VPNs are good and not so good. Yeah. There are good reasons to go with a VPN, and if you want to get into your home network remotely, securely, that makes a lot of sense. I don't need to do that. I have a few friends, well, one in particular that has to be in doctor's offices fairly often, has an issue with a cancer that's really rare. And I gave him access to my network attached storage device and all the music I've got on there, so we can sit there and listen to good music. Good music is stuff from the 60s and 70s, none of this new stuff. But anyway, I don't need a VPN to do that because I basically set up port forwarding and I've given him access. So when he gets in, it's not a problem. But yeah, there are good reasons to use a VPN. I don't have any of those good reasons. So you might want to talk about, since you're new to the group, you might want to talk about why do you use a VPN, and what you do and all that kind of stuff.
Okay. So my name is Brendan Sullivan. In terms of what I do, I work at a company called I do run a VPN in my house, primarily. They're relative to people that are in different countries that can't get.
Okay.
Yeah, that I do that.
No. Yeah.
That I was just wondering, I had an instance where I updated the firmware on it.
Zero. I know what they're for, and they make a lot of sense in some situations. I don't personally need it, so I haven't done it. But thanks, and welcome aboard. I know you're a dues paying member, and that's always good. We're a good bunch of folks. If you've got a problem, I'm assuming that you got my messages and you got the roster that was sent out by the
I'm all.
yeah. So call, email if you got an issue, and if you have ideas for presentations, please send them. I'm doing this today because we actually somebody suggested this, and I said, well, that's the one that I can do. So, Well, and seriously, call. If I can help or other folks, it's a good group.